Awesome, Dr. Powell. Let's take a look at how we're going to solve systems of equations using elimination technique, specifically for a 3 by 3. Now, it'll be convenient to arrange these equations so we have x's, then y's, then z's, and then the equal sign, and putting all these numbers just in an array like this called a matrix. This is a 3 by 4 matrix, 3 rows, 4 columns. So 3 for 3 equations, and 4 because you have 3 unknowns, and then you have something on the other side of the equal sign. Now, when we add equations together, notice that we like to combine like terms. Now, if we've arranged things like this, all our like terms are in this column. All the y's, right, are in this column, all the x's and all the z's. And so really adding 2 equations is like adding 2 rows together, or maybe you could subtract 2 rows, or you could multiply a whole row by something. And that's fine. You can multiply a row by something. You can add a row to something else. You can interchange the order of rows. That's just like interchanging the order of equations. You can also take an equation and just pick it up, pretend like it's in the air, multiply it by something, and then while it's multiplied, it really is the same equation as that, but maybe we just don't change this equation. So maybe like multiply this equation, and we use that multiple to add to another equation to change it, but then we like divide that equation by what we just did. And so kind of the idea to picture is you take an equation, you lift it in the air, multiply it by something, supply it with something in the air, and then drop it down on top of another one, and it changes that one. So that's that actually is one of the most common techniques that's used. For instance, if you added the bottom row to the top row, you'd end up with a 1 right here, which actually might be a good idea if we go in to see what our strategy is. The goal is to perform elimination equations one after another until you actually arrive at something that looks like this. This would be nice if our system of equations could turn into something like this, because what does this mean? This means 1 times x plus 0 times y plus 0 times z is equal to something. I just put stars here, but that's because I don't know what they are, but no matter what it is, it'll be x is equal to that thing if we write this out, because it's 1 times x and plus 0 is equal to that. So it'll be an x equals. This line will be a y equals. This line will be a z equals. In other words, we'll see what x, y, and z should be, and we'd write the solution as an ordered triple with an x value, the y value, and then the z value. So this is the goal. This is what we'd like to obtain by doing elimination. There's a strategy in order to do this. Step one is to first get the first column looking like this. Step 2 is to get the second column looking like this. Step 3 is to get the third column looking like this. Now, inside of each individual step, there's some things to think about. The first thing you want to do is get the 1 into position. And then if the 1's in position, actually that makes it easy to eliminate if there's other things, because you think, well, just think about this. If you have a 1, then you have a 2 right here. Then if you take this whole top row and multiply it by -2 and then add it to that guy, well, this guy would go away, and you've eliminated there in that equation. 1's are very nice. Use them to play with to eliminate. So first, get your 1 into position. After you get a 1 into position, then you're free to use that 1 to get zeros by doing an operation. Now, whenever you do a row operation or an equation operation, notice you're doing the whole equation to the whole next equation. So when you affect things in this column, you really are affecting things over here as well. The effect after step 1 is you're going to have a 1, 0, 0, and then you're going to have some other stuff over here. Actually, down here is what we're going to be looking at. This right here is kind of like a 2 by 2 system that your row operations will actually be solving at that point. But to make things even simpler, after we've solved it and we get a 1, 0, well, actually, even before we solve it, even if we just get this happening, we can even just go back up and use this this guy right here to eliminate what's up there and get a 0, and thus obtain our second goal, to get the second column to look like this. First by getting the 1 into position, then using that to play up and down. Now, the nice thing about doing this is, if we've gotten the first step done first, then when we get the 1 into position here, and whatever we've done, hopefully we have not used the top row really to add down, because whatever we do, we don't want to do operations that undo what we've already done. We want the first column to stay looking like this. So whatever we do, just make sure that stays. Normally that'll be accomplished by just kind of playing with these 2 rows down here, because zeros interacting with zeros will leave you with 0 in order to get the 1 into position. Once the 1 is in the position right here, then you can actually see you have a 0, 1. Then if you go back up here to get a 0 to eliminate, that 0 will interact with that 1, and that'll be okay. So, so as long as we go in the right order, we won't undo what we've already done. And we'll keep this, then we'll get that, then we'll get that, and we're for sure going to get the solution. It doesn't take too much in order to go from here all the way to here if we just follow the rules and the steps. So first do this, then do that, then do that. In each column, get the 1 into position first. Use it to play against the guys that are vertically from it to get zeros. Next, do this, get a 1 into position. You might have to swap rows or divide by something or add something to something else in order to get that 1 into position, and then use that to play against what's up and down. Then next, you do the same over here after you get this into position, and you go up. In the next video, we'll be using these ideas and this strategy to solve this system of equations. Thanks for watching.